Hey guys, today we're doing Leetcode 1650, lowest common ancestor of a binary tree 3. As you may be able to tell from the name of this problem, it's a continuation of lowest common ancestor of binary tree 1 and 2, with the addition that now we have a pointer to the parent of a given node. As a quick recap, the lowest common ancestor of two nodes P and Q in a tree T is the lowest node that has both P and Q as descendants. And an important point is that a node can be a descendant of itself. Hopping into a couple examples. If we're given the following tree where P and Q are 0 and 1, we can see that the lowest common ancestor is 3. And you'll notice that I made the ancestors of 0 blue, the ancestors of 1 red. And we can find the lowest common ancestor by walking through the parent nodes for P and Q until we hit a node that is in the path for both P and Q, in this case 3, which is the lowest common ancestor. Similarly, if we have P is 4 and Q is 0, then we walk both of those up to the parent, which is 9, and that is our lowest common ancestor. Now, if we have a case where P is 4 and Q is 3, we run into the case where a node can be a descendant of itself, and in this case, we would just walk up until we have 3 as our lowest common ancestor. Given that we like to find the intersection of the paths that we can achieve by walking from both P and Q up to their parent nodes, BFS is a natural solution here. We can implement this by keeping track of the nodes we've seen before as a set, creating a BFS queue, and then iterating through the nodes in that queue. If we pop off a node that we've seen before, then that means that it must be on both paths and we have our lowest common ancestor. If not, we'll just add that node to the queue and we will append its parents and then keep iterating. Now, since we're guaranteed there is a lowest common ancestor for this problem, we shouldn't have to worry about the case where we break out of the while loop before we return something, because that won't happen. In order to analyze the time and space complexity, we can go line by line through our solution. Creating a set is constant time, creating a queue is also constant time. Iterating through our while loop will take at most the max of the depth of node P or the depth of node Q, whichever is greater. Grabbing the current node off the queue is constant, as are all the other operations in our while loop. So the overall time complexity will be the max of depth P and Q. In the worst case, this could be O of the number of nodes in the tree. If we have a balanced binary tree, then it would be log of n, where n is the total number of nodes in the tree. Watch out for that, because frequently in interviews, I'll hear candidates say, oh, it's a binary tree, so the complexity is log n for suboperation. But that's predicated on the fact that it's a balanced binary tree, so make sure your interviewer clarifies whether it's balanced or not. It's not a balanced binary tree, maybe O of n. Given that we may have, at most, 2 nodes in the queue at any given time, that should only take up O of 1, but our scene set can have potentially all the nodes in the tree at one time, so our space complexity would be, at worst, O of n, but to make it a little tighter, it would be the max of the depth of P and Q. This question is another great example where breadth first search is actually a good solution for a tree-based problem. Again, like in the last video, kind of highlighted that frequently for these type of questions, depth first search recursively tends to be the easiest solution to write, but in this case, I felt that depth first search was not the easiest and breadth first search was easier. One point to note here is that I didn't actually return anything in the case where we broke out of our while loop and hadn't returned a node yet. This is because we're guaranteed that this problem has a valid solution that isn't none. But in an actual interview, a follow-up might be, how would we handle the case where there isn't a lowest common ancestor for 2 nodes, which would only happen if we had a tree that was disconnected. In that case, you might want to talk to your interviewer and really just communicate about what cases would cause that and how they would like to handle the resolution. That could be by returning none, it could be by returning something else like -1, but that would be up to you and your interviewer to figure out by communicating, because oftentimes in interviews, it's not just about knowing the algorithm, it's also about communicating efficiently and demonstrating that you're someone who can deal with vague problems, which you will inevitably encounter in an actual job.
Did you like this question? Do you have other questions you'd like me to solve? Let me know in the comments below, and be sure to like and subscribe if you enjoyed the video. Thanks, and have a great day.